Hello everyone. Today we'll be learning about Owasp Top 10. So Owasp Top 10 is a regularly updated list of the most critical web application security risks. So each item in the list represents a specific security risk which a web application should address in order to enhance their security posture. So this list is always updated in the if you see the trend, it is updated or released every 3 to 4 years. So the current one, which is the latest, is OS Top 10 2021, and hence we'll be taking up the list, the OS Top 10 2021, and discussing on top of that. So we can see like how, as I mentioned, always the list is updated, and mostly most of them remain same. It's just shuffled here and there. So if you see in 2017 OS 10 release, top 10 released, A1 was, or the first one was injection part, so which has moved to uh, the third section here in 2021. And again, if you see XML external entities, so this has moved to A5 from A0. So these all positions are just reshuffling, and some of them are being introduced newly in the top 10 lists. So this is a comprehensive list, but there are a lot of other things you should check. But these are the definite checks at least you should make in your application from the TOAS top 10 list. So we'll be just going through the top 10 ones for the list published in 2021 release. So the first one is broken access control. So what happens here is like there is inconsistent or insufficient access control, which is allowing the attackers to access unauthorized functionalities or sensitive data. So potentially it helps, what it does is it compromises the security of the web application. So here, you don't have the actual or the correct access controls being implemented, and here it may be insufficient, or there may not be consistency in the same. So like for example, there may be some admin page. So if you know about WordPress, so if you just give /wp admin, you should be seeing the WordPress page. So those kind of sensitive page or the functionality should not be available to non-admin users. Then coming to the second part, which is cryptographic failures. So here is like what happens is like the insecure implementation or improper usage of cryptographic functions are leading to the security vulnerabilities in the application. So there may be some TLS version which is outdated and still being used by your application. So those should be updated to the latest TLS version. Otherwise, it will be imposing the security vulnerability for your application. So some other examples for this case may be using weak encryption algorithms or storing encryption keys insecurely, which may result in compromise of sensitive data and the overall security of the system. And the third one in the list is injection. So injection vulnerabilities occurs when the untrusted data is sent to the interpreter as part of the command or query. So which is leading to unauthorized access or manipulation of data. So example of this may be the SQL injection, where attackers gets allowed to insert malicious SQL code in the input fields, which is potentially exposing or modifying the sensitive data in the database. So we should the measure we should take here is we should never trust the user input, and always have a sanity on the inputs being provided from the server as well as the user, which will have to sanitize the any kinds of inputs being passed which are not required. Similarly, there may be some command injection being allowed through some malicious commands, which may be executed by a user in the server. So proper input validation and parameterization are the essential part here to be taken care of to prevent injection attacks. Then the fourth one in the list is insecure design. So this is pretty new category in the 2021 release, which focuses on risk related to design flaws. So if we generally want to move left or shift left in the industry, it calls for more and more threat modeling, defining the secure design patterns and principles, and reference architectures. Example of this may be like there may be some security development life cycle in your applications which you want to uh, take care during the development life cycle, so that you make so that you ensure that all the security part is moving more and more towards the left side. Then the next is in the list is security misconfiguration. So security misconfiguration occurs when web applications are not properly configured, which leaves them vulnerable to potential attacks. So example of security misconfiguration include like if you have some default credentials, like you may be like you have may not have changed the default credentials and it remains admin, so which can be used by the attacker, or like you have some unhardened ports being available which are not being used but still available and listening. So in that case it can cause those kind of security misconfiguration, can allow like the vulnerable allow it to have some potential risk. So if you open this kind of ports which are not being used or the services are not being used or hardened, so in that case you are making the application vulnerable or to potential attacks. So the next in the list is vulnerable and outdated components. So this actually refers to usage of outdated third-party libraries or frameworks in the application. So example of this can be like the third-party jars or whatever you use for some functionality for your application. It may have some vulnerable component which is being used by you and exposing security risk for your application. Or maybe your OS is out of date as you have not patched and updated. So it can again pose a security threat or be a potential area of attack for your application. Then going to the next in the list is identification and authentication failure. So there may be inadequate or weak authentication methods which can lead to unauthorized access. It can also lead to privilege account takeover or privilege escalation. So example of authentication failures include weak password policies. So maybe you have not set the required password policy. So for example, it may be of 15 characters which you should implement. Then you should have some complexity like characters and special characters, integers, then maybe some other thing as part of the policy, so that you maintain that you should always have 15 characters minimum. Also, you should have some kind of 2FA or MFA or some kind of proper session management which can avoid those kind of identification and authentication failures. And the next in the list is software and data integration failures. So this refers to or this relates to the code and infrastructure that does not protect against integrity violations. So example of this can be like you can use some kind of digital signature or cryptographic hash so that you can verify that you are the only one using that, or maybe whatever the system is using, it can identify that these is the authorized one. So failing to maintain the software integrity may lead to unauthorized code modifications or unauthorized access to sensitive parts of the application. Then going to the ninth part, which is like security logging and monitoring failures. So this describes the need to have more and more monitoring and logging in place for all the systems. That is including the OS, access log, error log, as well as the application logs, and all the logging should be there. So inadequate logging hinders the ability to detect and investigate in case you have some security incident. So while if you have some if you have the ability of logging and all those things set up and you don't have monitoring, so what can happen is like it can delay delay the timely response to the potential attacks. So if you don't have logging or monitoring, then detecting the breaches may be very difficult, or maybe you are responding too late. And then the last section is server side request forgery, so also known as SSRF. So this allows an attacker to make an request to an unintended location. So input validation can be used to sanitize and validate all the client input data. So we can enforce some kind of URL schema, port, and destination which are allowed. So vulnerability here, what happens is like vulnerability where an attacker manipulates the web app to make unauthorized requests. So to internal and external systems. So your application may have some access to internal or external systems which are not authorized. So the attacker can use that and exploit it. So it can lead to data access as well as information disclosure and attacks on our internal infrastructure. So prevention again is like we should sanitize the input, validate it, and have minimum access control implemented wherever required, and always follow the minimum access control wherever required.